This or similar accidents can also occur on your MRI system if you fail to observe the safety regulations. With our products of the Magnetom family, we put patient and staff safety first. This video provides medical personnel with an overview of the basic safety precautions to be observed when using a magnetic resonance imaging system. You will be introduced to different magnets and learn how various magnetic fields affect people. Examples will show you the strength of a static magnetic field and the dangers faced when handling magnetic objects in the examination room. This video also addresses proper patient preparation and examination, as well as how to correctly handle the surface coils. Finally, we will show examples of emergencies or accidents and how to avoid them or react appropriately to them. Please be aware that this video does not claim to be complete and by no means replaces the system manual or operating instructions. Magnetic resonance imaging, abbreviated as MRI, is a diagnostic method for generating cross-sectional images of the human body. This method is based on the interaction between the human body and externally generated magnetic fields. In contrast to computed tomography, magnetic resonance imaging does not use ionizing X-rays, but uses static as well as slowly and quickly varying magnetic fields.
Physical principles. The patient is positioned in a powerful, homogeneous, constant magnetic field generated here by a cylindrical magnet. The strength of the magnetic field is indicated in units of Tesla, and today typically ranges between 0.2 and 3 Tesla. In comparison, the Earth's magnetic field is approximately 0.00005 Tesla. The static main magnetic field of a 1.5 Tesla magnet is approximately 30,000 times stronger than the Earth's magnetic field. The MRI is based on the magnetic properties of the most prevalent atomic nucleus in the human body, the hydrogen atomic nucleus, which is found in tissue and blood. The hydrogen atomic nuclei in the body's water and fat molecules align themselves to this main magnetic field. The alignment of the atomic nuclei is then systematically disrupted by an alternating magnetic field of suitable frequency. For a magnetic field of 1.5 Tesla, the frequency required to affect the hydrogen atomic nuclei is about 63 MHz, which is in the frequency range of radio waves. A transmitting coil in the magnet generates the alternating magnetic field in the area under examination. After being excited by high-frequency energy, the atomic nuclei return to the equilibrium position parallel to the static main magnetic field. The atomic nuclei then emit electromagnetic waves in the frequency range at which they were excited. Receiver coils arranged around the patient detect these weak RF signals. During excitation, and while the nuclei are returning to the steady state, spatially varying magnetic fields, known as gradient fields, are switched on so that the resonance frequency of the nuclei varies from one region of the patient to the next. This is how the spatial distribution of the atomic nuclei in the patient is coded into MR signals. A computer program analyzes the MR signals and generates an image of the distribution of the hydrogen atomic nuclei in the human body. The MR unit is housed in an RF enclosure. This ensures that the very weak signals from the RF pulses are not contaminated with interference and cannot cause radio interference themselves outside the enclosure. Therefore, the patient is exposed to 3 different magnetic fields during the MR examination. The static main magnetic field that aligns the atomic nuclei, the high-frequency alternating field that disrupts the alignment, and the pulsed gradient field that enables correlation of the MR signals to the location of origination. All 3 fields affect the patient differently. The static magnetic field used in MR does not cause any lasting side effects. The same is true for alternating fields when used properly. The rapidly switched magnetic field gradients in combination with the static main magnetic field are the cause of the considerable acoustic noise created during an MR examination. Since the coils generating the gradient field are located in the static magnetic field, A sudden force is exerted on them when the current is switched on or off. The resulting noise is similar to that of a loudspeaker in which a coil in the field of a permanent magnet causes a membrane to move. The noise increases with the strength of the static magnetic field and the gradient fields. The noise level of certain MR systems may require patients to wear hearing protection. In rare cases, quickly switching on and off the magnetic gradient fields can induce electric voltages in the peripheral nerves. These harmless voltages are expressed as a tingling sensation or mild muscular twitching. However, our MR systems are equipped with safety devices for controlling the switching speed and strength of the gradients to prevent nerve stimulation. The high-frequency alternating fields used for stimulating the magnetic resonance in magnetic resonance imaging are absorbed by the body and cause the irradiated body region to warm up slightly. For safety reasons, control circuits in the MR imager prevent the energy absorbed by the body, SAR, from exceeding a predetermined limit. Since the computation of SAR involves the patient's weight, it is important to enter this information correctly during registration. The limit values are fixed by international safety standards. Now, let's take a look at the heart of the MR system, the magnets. There are three types: permanent magnets, resistive magnets, and superconducting electromagnets. Permanent magnets always have a magnetic field. In case of an emergency, a permanent magnet cannot be switched off. They do not require an external energy supply and can only reach limited field strengths. In resistive magnets, the field is generated by a constant external current supply. The current flows through the wire coils and generates a large amount of heat in addition to the magnetic field. This heat is drawn off by a water cooling system. Resistive magnets only generate low field strengths since they are limited by the ability of the cooling water to dissipate heat. In case of an emergency, a resistive magnet can be switched off at any time. Superconducting magnets are used to generate higher magnetic field strengths. In this case, the wire coils through which the current flows are cooled by liquid helium to 4 Kelvin above absolute zero, which is minus 269 degrees Celsius. The current is provided by a power supply unit during installation, but once superconducting, it can flow without an external power supply for several decades. Once cold, the current flows continuously through the circuit and generates the static magnetic field. In case of an emergency, a superconductive electromagnet can be switched off at any time. For MR, the magnets are largely shielded so that their fields only act inwardly on the patient and quickly fade in an outward direction. This differs for various systems and depends on the field strength and design of the magnet. The use of magnetizable objects in the area of the fringe field is strictly prohibited, since the MR system exerts an attractive force on them. The 0.5 millitesla fringe field line is extremely important. A control area for the field strength in question is established around the magnet. The control area must be clearly marked and must adhere to the particular safety measures. Measured in the direction of the patient axis, the 0.5 millitesla line of this 0.2 Tesla system is 1.9 meters from the magnet center. In the case of a 1.5 Tesla system, it is 4 meters from the magnet center. Magnetic fields. The force exerted by an MR magnet on a magnetizable object depends on the degree to which the magnetic field changes spatially. This spatial change can be quite abrupt for shielded high-field magnets. The attractive force is powerful and arises suddenly. A metal chain is clamped to this cord. As the person approaches the system, the adjustable wrench becomes horizontal. Another experiment can be performed with a 1.5 and a 3 Tesla system. A scale shows the different forces on both systems. Compared to the weight of the scissor, the attractive forces are 50 and 100 times higher. Magnetic fields from magnetic resonance imaging systems are not directly perceptible, and their dangers are often underestimated. They exert an enormous attractive force on magnetic objects and objects containing magnetizable material. Can you imagine approaching the magnet with a set of keys in your pocket? Or forgetting to remove change, your lighter, or your pocket knife? And what about the dressing scissors? Ferromagnetic objects are attracted by the magnet and often cannot be held back. See for yourself. This melon simulates a patient's head. A hammer is accelerated toward the magnet and becomes a dangerous projectile. The magnetic field also influences watches, magnetic data storage media, and precision mechanical devices. When bringing devices and objects into the examination room, make sure ahead of time that they are not attracted to the magnet. Make sure you do not have any metallic objects on or in your body before entering the examination room. In an emergency, it is very important to know which non-magnetic rescue tools are available. Be informed. Magnetizable objects on the patient can result in significant errors. This also applies to magnetizable objects that remain unnoticed in the magnet. If possible, remove such objects from the magnet and notify your service engineer immediately. Remember, individuals with implants that can be affected by the magnetic field, for example pacemakers, are not allowed to enter the examination room. The same applies to metal implants or other objects in the body, such as prostheses, which are not MR safe. Remove all metal objects, such as scissors and keys. Remove all electric data carriers, mobile phones, and watches of all kinds. It is also forbidden to use fire extinguishers and oxygen tanks with a magnetizable metal casing inside the examination room. These objects are MR safe. This means objects in the MR environment which present no additional risk to the patient or other people, but may affect the quality of the diagnostic information. These objects are MR compatible. This means they are MR safe in the MR environment and do not significantly affect the quality of the diagnostic information, nor is their operation affected by the MR device. They are specially labeled and can be used without consideration. Attention! Only use equipment in the MR examination room which is MR safe or MR compatible.
Patient preparation and examination. Each MR unit should provide careful patient information in order to avoid surprises during the examination and to prevent risks for patients with contraindications. Patients entering the magnet room must be thoroughly checked and must fill out a screening form prior to an MR exam. A detailed questionnaire is essential. This includes the comprehensive medical history of each patient. Here are some of the most important questions. Does the patient have any allergies that could react to the contrast medium? Is the patient susceptible to seizures, for example, epilepsy? Did the patient undergo an operation? Does the patient have any passive or active implants, for example, clips or a pacemaker in his or her body? Does the patient have war injuries, for example, from shell fragments? Does the patient have any occupational diseases or injuries caused by welding or contact with iron? Does the patient have any tattoos or body piercing? Important questions. Drug allergies, seizure disorders, any type of operation, implants, war injuries, occupational diseases, tattoos, body piercing. Does the patient belong to one of the following risk groups? Does the patient suffer from claustrophobia or mental disorientation? Is the patient from the intensive care unit? Is the patient traumatized? Is the patient a child? Does the patient have inadequate thermoregulation that would prevent his or her body from releasing heat during the MR examination? Risk groups: confused or claustrophobic persons, intensive care patients, children, persons with inadequate thermoregulation. Persons belonging to these risk groups require special care by the physician and the MR personnel. This also applies to patients who are unconscious or not able to be addressed. In these cases, special attention must be paid to the medical history. All questions in the medical history questionnaire must be clearly answered. It must be signed by the patient as well as by medical personnel directing the patient care. If the patient is not able to answer the questions accurately, a family member should be consulted and must also sign. These questionnaires are to be added to the medical record. The physician cannot make a decision on whether an MR examination should be performed unless the questionnaire has been completely filled out. When examining pregnant women, a physician should clarify whether the indication is valid and whether there is possible danger to the woman or the fetus. Pay attention that MR examination may be contraindicated for patients with the following characteristics. Patients with certain implants, for example, pacemakers, ferromagnetic aneurysm clips, certain implanted electronic devices, certain electronic neurostimulators, cochlea implants and other hearing systems. Patients who do not know what type of implant or foreign object is in their body must undergo an X-ray or CT exam prior to the MR exam. Only after the physician has precluded all risk for the patient may the patient enter the examination room. Before entering the examination room, patients are required to remove the following objects from their person: cell phones, beepers, watches, jewelry, hearing aids, garments with metallic fasteners, hooks, wires or threads, metallic patches delivering medication, barrettes, hairpins, wigs, and prostheses. Makeup and deodorants containing metal alloys must also be removed. The patient must remove the following: metallic objects, cell phone, beeper, watch, jewelry, garments with zippers, hooks, wires, hearing aid, prostheses, wig, hairpins, makeup. The patient should wear clothing made of natural fibers and free of metal parts. In most cases, the clinic provides appropriate garments. Before positioning the patient, ensure that the coils and the cables are in proper condition. Defective coils can cause localized burns. Discuss with the patient possible allergic reactions to the contrast medium. This is especially important in the case of pregnant women and lactating mothers. While positioning, be sure not to trap any hair or crush extremities. Always ensure there's sufficient separation between the patient and the magnet bore. Always use the appropriate positioning devices for the safety and comfort of the patient. The patient should be positioned so that the legs and hands are not touching. They can form electrical current loops that act as antenna for the RF energy. Local burns may result. Permanent makeup, tattoos, and tattooing on the body must be documented and can be covered with damp compresses. Although this type of body decoration is not a contraindication, the patient must be informed that heating or distortion effects may result in the corresponding area. The same applies for other conductive materials, such as dental braces and body piercing jewelry. If the patient feels localized heating or burning sensations, the exam should be stopped. Provide the patient with hearing protection, headphones or earplugs, to safeguard against the noise level during the exam. When connecting the coils, ensure that cables are routed properly and are not touching the body. While positioning the laser-like localizer, patients must keep their eyes closed. Patients receive a squeeze bulb to hold. They can call for help anytime by pressing the ball. The exam can be interrupted immediately. Make sure that clothing and coils do not hang over the patient table. Sedated and helpless patients must be looked after by a nurse or a trained healthcare professional, and must receive physiological supervision for the entire duration of the examination. Switch on the intercom's listen mode. Before the exam, ensure that both the squeeze bulb and the intercom are functioning properly. MR technologists must be able to see and hear the patient at all times to monitor the patient properly. Now you can start the exam. Our medical products are developed and produced according to state-of-the-art technology and meet all relevant international safety standards. Most MR systems can operate in two modes: normal and first-level controlled operating mode. These modes are shown on the device. If one or more device parameters, such as gradient fields or high-frequency fields, are not in the normal operating mode, the patient has to be medically supervised, since certain groups may experience physiological stress. Exams may be performed by qualified and trained personnel only. Don't forget to brief persons such as rescue workers, firemen, workmen, and cleaning personnel who may be near the magnet for a short time only. In addition, inform personnel that smoking and open flames are not permitted in the vicinity of the magnet.
Hazards and emergency procedures. Emergency. To react properly, you have to be able to identify the type of emergency. In case of an accident caused by the electrical equipment, or in case of damage, press the emergency shutdown switch. In this example, the switch is located at eye level near the entry and exit points. Use it to disconnect the imager electronics from the line voltage. This does not turn off the magnet. If the patient is, for instance, caught between the gantry and the patient table, the table stop button must be pressed immediately. The stop button for the patient table is found on the right and left patient table control units and on the intercom. Pressing the button releases the brake so that the patient table can be moved manually. In the case of an extreme emergency, presenting risk of bodily harm and death, press the magnet stop switch immediately. The field strength rapidly decreases to a low value. This does not apply to permanent magnets. In this example, the magnet stop switch is above the emergency shutdown switch and is differentiated from it by the magnetic field label. Time saves lives. It is essential that you are informed about the appearance and location of the emergency switches right from the start. Also, make sure that external personnel, such as rescue workers, are briefed as well. Be aware to use only MR-compatible equipment. The emergency shutdown switch and the magnet stop switch may also be installed at different locations on the system. Operating personnel can find sufficient information in the manual to create suitable emergency plans. Emergency. Press the switch appropriate to the emergency or accident. Evacuate the patient immediately. Inform the rescue workers of danger of magnetic field. Only use MR-compatible equipment. Document the emergency or accident. In case of a life-threatening situation requiring the immediate dissipation of the magnet, press the magnet stop switch without delay. This will quench the magnet. This means that superconductivity breaks down and the magnetic field is dissipated within around 20 seconds. Helium escapes noisily through the quench pipe. Due to the low temperature of the helium, skin contact may result in considerable injury. If possible, leave the examination room with the patient prior to pressing the magnet stop switch and inform the service department immediately. A quench is quite expensive because the escaped helium has to be replaced. Quench. Patient and MR personnel vacate room immediately. Inform your rescue workers immediately. Inform your service engineers immediately.
For this reason, take the recommendations for operating personnel seriously and ensure regular maintenance of your equipment. Create emergency plans that describe the measures the patient, personnel, and rescue workers should take in response to potential dangers. Conduct regular emergency exercises with groups. Provide precise documentation of the emergency. Provide non-magnetic tools for cleaning, service, and emergency personnel. If you are aware of the effect of the magnetic field and observe the safety instructions, MR is a safe modality for a quick diagnosis. It affords unique views of the interior of the human body without ionizing radiation.